Hello students and good afternoon. So now I am doing class for class 12 science. The topic is the same topic that we were doing in the last online class, that is standard integral. So today is the continuation class of the same chapter, that is standard integrals. Same exercise 6b 4 mark section, page number 363 from the book Higher Mathematics for class 12 by Sailendra. So let's do this question number 9. And in the last online class we did question number 8. So let's do this question number 9 from the section 4 mark section, that is page number 363. So question number 9 is you have to integrate this question number 9, integral of dx divided by x root over 1 plus x cube. So how will you do this integration? So first of all, let us write integration I is equal to integral of dx divided by x root over 1 plus x cube. So actually you have to convert into standard integral form, but within square root we have 1 plus x cube and outside square root there is x. Actually this is 1 upon x, okay? So in this case also we can remove square root from 1 plus x cube by writing 1 plus x cube as z square. So let us assume this 1 plus x cube as z square. So let us write here, let z square is equal to 1 plus x cube. That is 1 plus x cube is assumed as z square. So you have to differentiate it. So differentiating both the sides with respect to x. So it is 2z into dz by dx is equal to, this is your 3x square. Is that clear? Now cross multiply it. So it is 2z dz is equal to 3x square dx. Is that clear now? But in this case, in I there is dx, only dx in the numerator. So you have to find out the value for dx from the numerator. In the numerator there is dx. So from here you get the value for dx. Or it is 2z dz divided by 3x square, which is equal to dx. Here z and x square both are the variables in this case, okay? So now let us put it in I. So what does I become now? So therefore I is equal to integration of, what is dx? The value for dx is 2z dz. It is 2z dz divided by 3x square upon, in the denominator this x, keep it as it is. So it is x, then root over, what is 1 plus x cube? It is z square, right? So here you can put z square. Is that clear? So or I is equal to, which is the constant in this case? 2 by 3. So it should be taken outside. So 2 by 3 is taken outside, integral sign, integration of, so this is z dz divided by, now this x square and x both are in the denominator and they can be multiplied. So x into x square is x cube. They cannot be cancelled because both are in the denominator, that is x square into x is x cube, into what is root over z square? That is your z. Here z gets cancels. So or I is equal to, this is 2 by 3 integration of dz divided by x cube. So now you have to express, now in this case we get integration of dz divided by x cube. Now we have to express x cube in terms of z. What is x cube in terms of z? Because there is dz. So you have to express x cube in terms of z. So from here you can get the value for x is x cube. So x cube is equal to, what is it? X cube is equal to z square minus 1. X cube is equal to z square minus 1. So let us put it out here. So or I is equal to, this is 2 by 3 integration of dz divided by, this is what? X cube is equal to z square minus, this 1 can be written in terms of 1 square. So what is the value for x in this case? It is z. What is the value for a in this case? It is 1. So this is your x square minus a square. So this is second standard integral. What is second standard integral? Integration of dx divided by x square minus a square. So what is the formula for this standard integral? It is 1 by 2a. It is 1 by 2a log within mod. It is x minus a upon x plus a mod sign closed base e then plus c. So this is your base e, right? So this is your base e. Is that clear? So instead of x here there is z. Instead of a here it is 1. So we can use that formula, isn't it? So let us use the formula. I is equal to 2 by 3 into, what is the formula? 1 by 2a. 1 by 2 into, what is a? 1 log within mod, what is x minus a? Z minus 1 divided by z plus 1 mod sign closed. Then base is e and you have to write plus c. Okay. Now in this case you can cancel these two, cancel it. Put the value for z. What is the value for z in this case? What is z square is equal to 1 plus x cube. So what is the value for z? It is root under 1 plus x cube. Let us write it here now. Or the final answer is I is equal to 1 upon 3, right? This is 1 upon 3. Then log log within mod. What is z? It is root under 1 plus x cube. Root under 1 plus x cube. Then you have to write minus 1 divided by, again what is z? Root over 1 plus x cube. Root over 1 plus x cube. Then what do we write? Plus 1. Plus 1 mod sign closed. The base is e and it is plus c. So this is the final answer. Is that understood now? So you can copy it. So this question is also very, very important. So you can copy it. Now we'll do the next question. So now let's do the next question, that is question number 10. Integrate. That is, you have to integrate this integral sign dx divided by x into within second bracket log x whole square minus 6 log x plus 5. So how can you evaluate this integration? So here directly you cannot convert into perfect square and then use standard integral. So in this case, first of all, you have to do the method of substitution. So you have to check the relation between log x and 1 by x. So what is the relation between log x and 1 upon x? Differentiation of log x is 1 upon x. So first of all, in this case, you have to do the method of substitution. So let us write here, I is equal to integration of dx divided by x within second bracket. It is log x whole square minus 6 log x then plus 5. Is that clear? So now in this case we can assume log x as z. That is the method of substitution. We can substitute log x as z, okay, because the differentiation of log x is 1 by x. So let z is equal to log x. So differentiating both the sides with respect to x. So it is dz by dx is equal to, this is 1 upon x, or what is the value for dz now? So dz is equal to dx upon x. So we have got the value for dx upon x. That is, in this case there is dx upon x. That's why we are getting the value for dx by x, which is equal to dz. Okay. So what does I become now? So I is equal to integration of, that is dx upon x is dz, right? So we can write here dz divided by, so it is z square. Z square minus 6z plus 5. So in this case, dx upon x is dz. Log x whole square is z square minus 6z plus 5. Is that clear to all of you? So I think you have understood it. Okay. So now this z square minus 6z plus 5 is there. There is quadratic expression in the denominator. But you can factorize it, isn't it? Or you may convert it into perfect square and then you can use standard integrals. Or you may factorize it. You can factorize it, so factorize it. Okay. So you can do the middle term breaking here. Z square minus 6z plus 5, you know how to do middle term breaking, isn't it? So which is equal to z square minus within bracket 5 ones are 5, 5 ones are 5, and 5 plus 1 is 6. So 6 is separated here as 5 plus 1. So this is the middle term breaking. So which is equal to z square minus 5z minus into plus minus z plus 5. Okay. So which is equal to z within bracket z minus 5 minus 1 common. So this is z minus 5, right? Which is equal to z minus 5 into this is z minus 1. So this is your factorization of z square minus 6z plus 5 by middle term breaking. Okay. So let us put it out here. Or I is equal to integration of this is dz divided by. So what is this factorization? It is z minus 5 into z minus 1. So I think you have understood it. Okay. So let us convert this fraction, that is 1 upon z minus 5 into z minus 1. This is the product of two fractions. So let us convert it into partial fraction form. Okay. So you know partial fraction. So let us assume let 1 upon this is z minus 5 into z minus 1 is equal to capital A upon z minus 5, okay, plus capital B upon z minus 1, and let us mark it as number 1. Okay, so it is marked as number 1 because you have to get those values of constant A and B and put them and put the values of A and B in number 1. So let us simplify it. In order to get the values of A and B, let us simplify it. So 1 upon this is z minus 5 into z minus 1, which is equal to, so what's the LCM out here now? It is z minus 5 into z minus 1. So what is there in the numerator? So this LCM is divided by z minus 5, so z minus 1 remains. So A into z minus 1 plus B into, again this LCM is divided by z minus 1, so it remains z minus 5. So B into this is z minus 5. So I think you have understood it. Okay, so you can cancel these denominators, cancel it, or 1 is equal to A into z minus 1 plus B into this is z minus 5. Is that clear now? So now in this case, in order to get the value for A, you have to make this second term 0 by putting some values of z. If you put z is equal to 5, this second term will be 0. You can easily get the value for A. So putting z is equal to 5. So putting z is equal to 5, what do we get? 1 is equal to A into 5 minus 1. This will be 0. Or what is the value for A? A is equal to 1 upon 4. So I think you have understood it. Okay. So now in order to get the value for B, you have to make this first term 0 by putting some suitable values of z. If you put z is equal to 1, this term will be 0. You will get the value for B, isn't it? So in this case, you putting z is equal to 1 so that this first term will be 0. So therefore 1 is equal to this term is 0, B into this is 1 minus 5, right? Or 1 is equal to B into this is minus 4. Or what is the value for B here? In this case, it is minus 1 upon 4. So I think you have understood it. So we get A is equal to 1/4 and B is equal to minus 1/4. So let us put those values of A and B in 1. So putting the values of a and b in 1. So let us put those values of a and b in 1. So what do we get? This is 1 upon z minus 5 into z minus 1, which is equal to, what is capital A? It is 1/4 divided by z minus 5. What is b? It is minus 1/4. So plus and minus is minus. It is 1/4 divided by, this is your z minus 1. So that is number 1. So we have put those values of a and b in 1. So I think you have understood it. So we have converted this fraction into partial fraction, right? So this is known as partial fraction. Let us put these values in I. So we'll put here I. So therefore I is equal to integral sign within bracket. So now instead of this fraction 1 upon z minus 5 into z minus 1, what should we put? 1/4 upon z minus 5 minus 1/4 upon z minus 1. Let us write it here. So this is 1/4 divided by z minus 5 minus 1/4 divided by z minus 1, right? Divided by z minus 1, bracket closed. Then what do we write here? dz. Now we can easily separate this term, isn't it? For product 1, we cannot separate the term. For the difference or the summation, you can easily separate the integral sign and dx, and then you can easily integrate them. So, or this is I is equal to 1/4 integration of dz divided by z minus 5. This is minus 1/4. It is integration of dz divided by, this is z minus 1. So I think you have understood it. So now this is not the standard form because the power of z here is 1. So you can take this z minus 5 or z minus 1 as z, and then you can easily integrate it as integral sign dz upon z. So what is integration of dz by z? It is log z. Okay. So here it is I is equal to 1/4 log within mod z minus 5, the base is e, right? And this z minus 5 was assumed as z. And again you have to differentiate the function which is assumed as z with respect to z. So what is the differentiation of z minus 5? It is 1. So it is whole thing divided by 1 in case of integration. So since it is 1, you don't have to write it, okay? Then minus, this is 1/4. This is also log within mod z minus 1, the base is e. Then what do we write? Plus c, okay? So what is common out here? 1/4. So here 1/4 is taken common. If 1/4 is taken common, it will be in the form of log a minus log b. What is log a minus log b? Log of a by b. So it is log of z minus 5 divided by z minus 1. The base is e, then plus c. But this is not the answer because you have to write down the answer in terms of x. So you put the value of z. What is z actually? Z is equal to log x. So let us write here now, or I is equal to, this is 1/4 log within mod. What is z? What is z actually? It is log x. It is log x minus 5 divided by what? It is log x minus 1. Mod sign closed. The base is e, then plus c. So this is the final answer. So I think you have understood it. So this question is also very, very important. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 11. So you have to integrate integration of x plus 2 dx divided by x square minus 3x plus 2. So in this case also we see that we can factorize the denominator, that is x square minus 3x plus 2 can be factorized. Let us factorize it and then you can convert it into partial fraction. So in this case you can convert this fraction into partial fraction because the power of x in the numerator is less than the highest power of x in the denominator. So you should keep in mind that the highest power of x in the numerator must be less than the highest power of x in the denominator. Then only you can factorize it and then convert to partial fraction. But if the highest power of x in the numerator is equal or greater than the highest power of x in the denominator, then you have to divide the numerator by the denominator first. Okay? But if the highest power of x in the numerator is less than the highest power of x in the denominator, then you can factorize the denominator and you can convert into partial fraction. Is that clear? So in this case, the highest power of x in the numerator is 1 and the highest power of x in the denominator is 2. Okay? That is, the highest power of x in the numerator is less than the highest power of x in the denominator. And you can factorize this denominator. So we can factorize it and then you can convert them into partial fraction. So is that understood now? So let us write it first as I is equal to integration of x plus 2 bracket close dx divided by, this is x square minus 3x plus 2. Is that clear now? So I think you can factorize this denominator. You can factorize it. So it is x square minus 3x plus 2. Let us factorize it by middle term breaking. Okay? So if you multiply the two numbers, you should get 2, and after adding, that is before 2 there is positive sign. So after adding you should get 3. So that is 2 ones are 2 and 2 plus 1 is 3. Okay? So it is x square minus, this is 2 plus 1 into x plus 2. So which is equal to, this is x square minus 2x minus into plus minus x plus 2, which is equal to, what is common here now? X within bracket x minus 2. Here minus 1 is common, so it is x minus 2, which is equal to x minus 2 into, this is x minus 1. So we have got the factors by middle term breaking. Okay? So let us write them here, factors, or I is equal to integral sign, this is x plus 2 dx divided by, what is here now? It is x minus 2 into x minus 1, x minus 2 into x minus 1. Is that clear to all of you? So now we can use partial fraction. So now here we can use partial fraction method. So let us convert this fraction into partial fraction. Okay? So let x plus 2 divided by x minus 2 into x minus 1. So whatever is there in the numerator, but the highest power of x in the numerator must be less than the highest power of x in the denominator. So always you have to assume it as capital A upon first factor. What is first factor? X minus 2. You can write either plus or minus. You may write minus also. Okay? So plus, let us write plus here. Then you should write capital B. Whatever expression may be there in the numerator, always write A upon first factor plus B upon second factor. What is second factor here? It is x minus 1. Let us mark it as number 1. Is that clear? So let us simplify it to get the values of A and B now. So the problem, so now the method is same as we have done in the previous one. So, or it is x plus 2 upon x minus 2 into x minus 1, which is equal to, what's the LCM here now? It is x minus 2 into x minus 1. Now this LCM is divided by x minus 2. So it remains only x minus 1. So x minus 1 is multiplied by A. X minus 1 plus B into what? Now this LCM is divided by x minus 1. So x minus 1 will be cancelled. You will get x minus 2. So this is your x minus 2. So here you can cancel this x minus 2 and x minus 1 will be cancelled. Or what do we get? X plus 2 is equal to A into x minus 1 plus B into, this is x minus 2. So I think you have understood it. Okay. So now in order to get the value for A, you have to make this second term, that is term containing B, as 0 in order to get the value for A. So you put x is equal to 2 here. So putting x is equal to 2 in this case. So what do we get? You have to put 2 on the left hand side also. So 2 plus 2 is 4 is equal to a into this is 2 minus 1, and this will be b into 2 minus 2 is 0. Okay. So what is the value for a? That is a is equal to what? It is 4, because 2 minus 1 is 1. So we have got the value for a. That is a is equal to 4. So now in order to get the value for b, you have to make this first term 0 by putting x is equal to 1. So putting x is equal to 1 now. Putting x is equal to 1 now. What do we get? 1 plus 2 is 3. This will be 0, and this is b into 1 minus 2. Therefore 3 is equal to b into minus 1. That means it is b is equal to what? It is minus 3. So we have got both the values of a as well as b. So let us put these values of a and b in 1. So putting the values of a and b in 1. So let us put those values of a and b in this 1, right? So therefore x plus 2 upon x minus 2 into x minus 1, x minus 2 into x minus 1 is equal to, what is capital A? It is 4. So 4 upon x minus 2. This is 4 upon x minus 2. Then what is b here? It is minus 3. So you put minus 3 here. Plus into minus is minus 3 upon x minus 1. Minus 3 upon this is x minus 1. So I think you have understood it. So we have converted the given fraction into partial fraction. This fraction is converted into what? Partial fraction. So now instead of this fraction, we will put this partial fraction. Okay. So this I is equal to, integral sign within bracket. What is the value of this fraction? What is this partial fraction? It is 4 upon x minus 2 minus 3 upon x minus 1, bracket closed. Then you have to write dx. Is that clear? So let us separate the term, or I is equal to 4 integral sign dx upon x minus 2 minus 3 integral sign, this is dx upon x minus 1. Is that clear? So now this is also not the standard integral. Okay. So here the power of x is 1. So x minus 2 and x minus 1 can be taken as x, so that you can directly integrate them. Okay. So dx by x is log x, you know that. So I is equal to 4 into log within mod x minus 2 mod sign close, the base is e whole divided by 1. How did you get that 1? Again you have to differentiate the term which is assumed as x. That is, differentiation of x minus 2 with respect to x is always 1. So it is dividing by 1. So since it is 1, you don't have to write it. Okay. So minus 3 into log within mod, this is x minus 1, and here the base is e, then it is plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. Now suppose if this denominator cannot be factorized, you cannot convert it into partial fraction form. So in that case, you should do the different method. Now I'll show that method. Okay. If the fraction, if this denominator, in this fraction, if this denominator cannot be factorized, then you have to use the different methods. But in this case, you can factorize the expression. So it is, this fraction is converted into partial fraction, then you can easily do it. Okay. But if the denominator cannot be factorized, then you have to use different methods. Now I'll show that method now. Okay. So before that, you can copy it. So now we'll do next method now. So there is method for integrating integral sine px plus q divided by ax square plus bx plus c dx. Now in this case, the highest power of x in the numerator is 1, that is px plus q, and you know that this is known as linear expression in x. And in the denominator there is highest power of x is 2, this is known as quadratic expression in x. So in the previous problem, in that case the denominator can be factorized so that it can be converted into partial fraction. Now sometimes this denominator cannot be factorized. Okay, so in that case you have to use the different methods, but this should be the form, that is in the numerator the highest power of x should be 1, which is the linear expression in x, and in the denominator there should be highest power of x as 2, which is the quadratic expression in x. Now suppose this denominator cannot be factorized, so how will you do it now? So let us write here I is equal to integral sine, this is px plus q divided by ax square plus bx plus c, then what do we write? Dx. Is that clear now? So now in this case the highest power of x in the denominator is 2, ax square plus bx plus c, that is the quadratic expression, and in the numerator there is highest power of x as 1, this is known as linear expression in x. But in this case the denominator cannot be factorized. So what is the method here? So now in this case the method is, now listen it carefully, the method is you have to write down the differentiation of the denominator in the numerator. हामी यहाँ के गर्छौं, यो डिनोमिनेटरलाई डिफरेन्शिएट गर्छौं with respect to x, यसलाई हामी न्युमरेटरमा लेख्छौं, ठीक छ? So or I is equal to, the method is in this case write down the differentiation of the denominator in the numerator. Okay, so what is the differentiation of the denominator? It is 2ax. What is the differentiation of bx with respect to x? B, and for c it is 0. Keep it within bracket. Is that clear? So we are getting 2ax plus b, which is the differentiation of the denominator. But you should get px plus q after simplifying this, 2ax plus b. Okay, so let us simplify. Let us check first 2ax. There is 2ax, but there is px. You should get px here. By which term or by which number or by which term will you multiply this 2ax to get only p? You have to cancel this 2a, isn't it? 1 upon 2a. If it is multiplied by 1 upon 2a, 2a will be cancelled. You will get only x, and it should be multiplied by p. That means if this expression is multiplied by p by 2a. If you multiply this expression 2ax plus b by p by 2a, so what is the product? P by 2a into 2ax. 2a will be cancelled. You will get px. So that is correct. Okay. But if you multiply p by 2a by b, what do we get? pb by 2a. Is there pb by 2a? No, we don't have. You have to subtract it. First you write q, plus q is there, plus q, and minus, what will you write? Since pb by 2a is not there, you have to subtract it. So it is pb divided by 2a. Bracket closed. Whole divided by, what do we write? ax square plus bx plus c. Then what do we write here? It is dx. So I think you have understood it. Now we have to separate this fraction. Is that clear? Now we have to separate this fraction. So you have to separate this integral sign and dx also. You can simultaneously separate fraction as well as integral sign and dx. Okay. So what do we get now? So or I is equal to, this is, what is p by 2a? Constant taken outside. Integral sign, so it is 2ax plus b into dx divided by, it is ax square plus bx plus c. Is that clear to all of you? Next, plus this q minus pb by 2a is constant. So we can write within bracket q minus pb by 2a q minus pb by 2 is constant, that is taken outside. Integral sign, then you have to write down integral sign dx divided by what? This is ax square plus bx plus c. So this is the method. You can easily do it now. So or I is equal to, it is taken as I1 and this taken as I2. Then you can easily integrate them. Okay. So for I1 you can do the method of substitution because differentiation of the denominator is the numerator. Is that clear? And in this case for I2 you can convert into standard form. Okay. You can convert this ax square plus bx plus c as a perfect square form, and then you can convert it into standard integrals so that you can use the formula from 1, 2, 3, 4, 5 and 6. Okay. So this is only the method. I think you have understood it. So you can copy it. You can copy the method. So now we'll do this type of problem. Okay. So now we'll do this type of problem, that is in this case the denominator cannot be factorized. Okay, so it is, you have to integrate integral sign x plus 2 dx divided by 2x square plus 6x plus 5, and in this case this 2x square plus 6x plus 5 cannot be factorized. Okay, so let us write here I is equal to integration of, this is x plus 2 dx divided by 2x square plus 6x plus 5. So now what is the method here? If the denominator cannot be factorized, so you have to write down the differentiation of the denominator in the numerator. Okay, so in the numerator you can write down the differentiation of the denominator. So or I is equal to integral sign, what is the differentiation of the denominator? For 2x square it is 4x plus 6. Is that clear? So since there is 4x, but here it is x, but you cannot write minus 3x. If you write minus 3x, it is just like adding the variables. If you add the variables, again you have to separate it and again you have to integrate it. Okay, so you cannot add or subtract the variables out here. Okay, since 4x is there, by which constant will you multiply this 4x to get only x? By which number or by which constant will you multiply this 4x to get only x? 1/4, isn't it? So it is 1/4. Is that clear? So if you multiply this 4x by 1/4, it will be only x. So that is correct. But what is 6 by 4? What is 6 by 4? It is 3 by 2. 6 by 4 means in the lowest form it is 3 by 2. Is there 3 by 2 here? No. So what do you write? First you write plus 2, write down plus 2. And since this is 3 by 2, is there 3 by 2? No, you have to subtract it. So it is minus 3 by 2. Bracket closed. Whole divided by, this is 2x square plus 6x plus 5. Then what do we write here? Dx. Okay, so let us simplify it. Or I is equal to integration of 1/4 within bracket 4x plus 6 plus, what is 2 minus 3 by 2? 2 2s are 4 minus 3. It is half divided by 2x square plus 6x plus 5. Then what do we write? Dx. Okay. So now we can separate the term. I is equal to, separate the term now. This is 1/4 is constant taken outside. Integration of, this is 4x plus 6 dx divided by, it is 2x square plus 6x plus 5. Is that clear? Plus half is constant, it is taken outside. Half integration of dx divided by, what is there in the denominator? It is 2x square plus 6x plus 5. So I think you have understood it. Okay, so now we can easily integrate this to integration. Now differentiation of this denominator is the numerator, isn't it? We can use this formula, that is, you know, from method of substitution, f dash of x dx divided by f of x. So which is equal to, what is this integration? So in this case, the relation between f of x and f dash of x is differentiation of the denominator is the numerator, isn't it? That is, differentiation of f of x is f dash of x. So what is the formula? It is log within mod f of x mod sign close base c plus c. Similarly, differentiation of the denominator is the numerator, isn't it? That is 2x square differentiation 4x plus 6. That means we are getting the numerator after differentiating the denominator. Okay, so what is the formula that you can use here? It is I is equal to 1/4 log within mod, what is f of x here? 2x square plus 6x plus 5 mod sign close, the base is z, plus you can write it as I1. So let us mark this integration as I1. So let us find out the value for I1 now. So what is I1 here now? So I1 is equal to, it is half integral sign dx divided by, it is 2x square plus 6x plus 5, isn't it? It is 2x square plus 6x plus 5. Now let us integrate it. Okay, now there is 1 in the numerator, and in the denominator we have 2x square plus 6x plus 5. Now this cannot be factorized, so you have to convert it into standard form. You have to convert it into perfect square form first. So before that, I told you that you have to convert, or you have to express the coefficient of x square as positive 1. You have to make the coefficient of x square as positive 1, as we have done in previous problem. That means you should take 2 as common, isn't it? So, or I1 is equal to, this is half integration of dx. So make the coefficient of x square positive 1. So 2 is taken common. So it is x square plus 3x plus, this is 5/2. Is that clear to all of you? So I think you have understood it. Okay. Now this is half again, that is constant. It is taken outside. So I1 is equal to 1/4 integration of dx divided by, this is x square plus 3x plus 5/2. Understood now? So now again there is x square plus 3x. There is term containing x square and x. I already told you in the previous problem that if you have got the expression like x square and the term containing x, you should convert it into perfect square form. That is a square plus 2ab plus b square, or it may be a square minus 2ab plus b whole square. Okay, so let us convert into a square plus 2ab plus b square form, right? So I1 is equal to 1/4 integration of, this is dx divided by, what is a whole square? It is x whole square plus 2 into x into a square plus 2a. What should be the value for b here? We are getting this x square is correct, but there is 2x, but here we have got 3x. So what should be the value for b here? So that after multiplying that b with 2x, you will get only 3x. That means by which number will you multiply this 2x to get 3x? 3/2, isn't it? So it is 3/2 plus, so that 2 will be cancelled and you'll get 3x. Okay, plus what is b whole square? It is 3/2 whole square. It is 3/2 whole square. Is that understood? So now we are getting this x square is correct, 2 gets cancelled, 3x is also correct. But what is 3/2 whole square? It is 9/4. Is there 9/4? No, only 5/2 is there. So first of all you write 5/2. Okay, then 9/4 is not here, so write 9/4. So you have to write 5/2, because 5/2 is here, write down 5/2. What is 3/2 whole square? It is 9/4. Is there 9/4? No, write down minus 9/4. Okay, you have to subtract it. Okay, so or I1 is equal to 1/4 integral sign dx divided by, in the denominator, this is a square plus 2ab plus b whole square. What is the formula? it is x plus 3 by 2 whole square. Is that clear? Next, plus, what's the LCM? 2 and 4. For 2 and 4, what's the LCM? 4. This 4 is divided by 2, that is 2. 5 2s are 10. And this is minus 9. 4 by 4 is 1. 4 divided by 4 is 1. 1 into 9 is 9. Okay? So, or I1 is equal to, this is 1/4 integral sine dx divided by, this is your x plus 3 by 2 whole square plus. So, it is plus, isn't it? Understood? So, next, what is 10 minus 9? 1. It is 1/4. 10 minus 9 is 1. 1/4. 1/4 means half whole square. 1/4 you can write it within whole square. That is your half whole square. So in this case, the value for x here is x plus 3 by 2 and a is half. So this is the standard form, that is integral sine dx divided by x square plus a square. That is the first standard form. So which is equal to, what is the formula? It is 1 upon a tan inverse x upon a plus c. We can use this formula in this case. Okay. So let us write it here now. Or I1 is equal to 1/4 constant is there. You have to write it. Right, 1/4 into, now write down the formula. What is 1 by a? 1 upon, what is the value for a in this case? Constant half. 1 upon 2. Then you have to write tan inverse within bracket. What is x? X plus 3 by 2. It is x plus 3 by 2 divided by, what is a? A is half. A is half, bracket closed, plus c. So I think you have understood it. Okay. So let us simplify it further. 2 1s are 2. This is 2 2s are 4. Or this is your I1 is equal to half. Next, tan inverse. So within bracket, what is the LCM in the numerator? That is 2. 2 is the LCM. And this 2 and this 2 will be cancelled. You will get only 2x plus 3, bracket closed, plus c. What happens to that 2? 2 will be cancelled. So we have got the value for I1. Okay. But this is not the answer. Again, you have to put the value for I1 in I to get the answer. Right. So what is the final answer now? Therefore, I is equal to. So I is equal to, let us write down the first term here, 1/4 log. 1/4 log within mod, what is here? It is 2x square plus 6x plus 5. 2x square plus 6x plus 5. The base is e, right? The base is e, then plus I1. So this is the continuation part, plus. What is the value for I1 here? What is I1? Just now we got it. What is I1? It is half tan inverse within bracket, it is 2x plus 3, bracket closed, plus c. So this is the final answer. So what is I here? What is the answer for I? It is 1/4 log within mod 2x square plus 6x plus 5 mod sign closed base e plus half tan inverse within bracket 2x plus 3, bracket closed, plus c. So that is the final answer. So I think you have understood it. So this question number 13 will be a homework. You can do it at home. Okay. So I'll give you the hint for 13. That is, you have to integrate 2x plus 1 dx divided by x into x plus 3. So here also, if you multiply the denominator, the power of x will be 2 and the highest power of x in the numerator is 1. That is 2x plus 1. So highest power of x in the numerator is 1, but the highest power of x in the denominator is 2. So since the denominator is already factorized, so you can do the method of partial fraction. So we can convert this fraction in terms of partial fraction as, let 2x plus 1 upon x into x plus 3 is equal to capital A upon first factor, that is x, plus capital B upon second factor, that is x plus 3. Mark it as number 1, simplify it and get the values of a and b as we have done in the previous problem. So this question number 13 is your homework. So I have given you the hints. So do it at home. So question number 13 is your homework. Okay. So this much is for today. So this question is very, very important. That is question number 12. So 13 is your homework. So revise all the problems that we did today. So in the next online class, we'll do more problems on this standard integrals. So this much is for today. Okay. So you can copy it.